Suppose you rent a truck for a day to move some furniture at $20 a day and 90 cents a mile driven. Write the equation of the line that will describe the total that you will pay. Our slope is given by the 90 cents a mile. Every mile that we drive will multiply that number of miles by 90 cents, and then our y-intercept value is given by the $20 a day set fee. So our equation will be 0.90 times x plus 20. So if I drove 100 miles, I would pay 90 cents times 100 miles plus the initial $20, and I would pay $110. A lake with 1,000,000 gallons initially is being drained 2,000 gallons a day. Write a linear equation that accurately describes the amount of water left in the lake X days after it started to rain. The 2,000 gallons a day gives us our slope. It should be negative 2,000. So negative 2,000 times the number of days will be added then to our initial value of 1,000,000. So the y-intercept value is 1,000,000. So y equals negative 2,000x plus 1,000,000 is the equation of our line. So if 20 days went by, the amount of gallons left in the lake would be negative 2,000 times 20 plus the initial million, giving us 960,000 gallons left in the lake. 75 minutes after Darci left on a bicycle trip, she was at mile marker 224 on the Downey Road Bike Trail. 3 hours after she left, she was at mile marker 258. Let us use the points 1.25, 224, and 3, 258 to find a linear equation that will track Darci's location on the Downey Road Bike Trail. And let's assume she maintains generally the same pace over long distances. 75 minutes is 1 hour and 15 minutes, so it's 1.25 hours. Let us first find the slope of our line. So our y-coordinates are the mile markers, 258 and 224. So finding their difference is the numerator of my slope, and the hours are 3 and 1.25. Those are the x-coordinates of my points, so their difference will be the denominator of my slope. And if I find the difference in the y's and divide by the difference in the x's, I get 19.43, and that's actually her average speed or her rate. If I take her rate of 19.43 miles per hour and I multiply that by one of the times, let's just take the 1.25, that product added to B should equal the mile marker 224. 19.43 times 1.25 is 24.2875, so 224 minus 24.2875 gives us 199.7. So she entered the trail at 199.7 miles. There probably wasn't a mile marker right at that spot, but if there was, that would be the mile marker where she came onto the trail at the beginning of her ride. So our equation is y equals 19.43 times x plus 199.7. We could use this equation now to find various information about her bike ride. For example, if you plug in 5 hours and 10 minutes or 5.16 hours approximately, and you follow the linear equation, you get mile marker 300. So if she was aiming to reach mile marker 300, she could use the equation of this line to figure out how long it was going to take her, assuming she maintained the general same pace. For the period of 1951 to 1980, the average global temperature was estimated by NASA to be 14 degrees Celsius. Since then, the average global temperature has risen 0.18 degrees Celsius per decade. Write a linear model that will estimate the average global temperature with input year since 1980. Our output will be the average global temperature. Estimate the average global temperature then in 2015 using your model. Here we actually don't have any calculation. Well, we have a little bit of calculation. The y-intercept value is given to us. We're going to use 14 as our base value in 1980, and the temperature has been rising at a rate of 0.18 degrees Celsius per decade, but we're supposed to use an input of years since 1980. So divide 0.18 by 10 and you get 0.018, and that is the rate per year. So our formula, y equals mx plus b, slope times x plus your beginning value, will be 0.018x plus 14. 2015 is 35 years after 1980. So if you take 0.018 and multiply by 35 and then add that to the beginning value of 14, you end up with an average global temperature of 14.63 degrees for 2015. Shamika's Best Cupcakes found that when she priced her fanciest cupcakes at $5.50, she sold on average 288 per week. When she ran a special for a long period of time with the fanciest cupcakes priced at $4.75, she sold on average 408 per week. An equation that relates quantity sold to price is called a demand equation in business applications. For a set interval of prices, it can be used to help predict sales and revenue. Assume a linear demand function for Shamika with price as input and quantity sold as your output. We'll use the points 5.5, 288, and 4.75, 408 because we're using the price as our input and the quantity as our output. Using these 2 points then, our slope will be the difference in the y values, 408 minus 288, divided by the difference in the x values, 4.75 minus 5.5, and that gives us a slope of negative 160. Then to find b, choose one of the points. I'll just choose the $5.50 with the 288 and plug $5.50 in for x. Negative 160 times 5.5 then added to b should equal 288 if we're actually finding the equation of the line we're looking for. So negative 160 times 5.5 is actually equal to negative 880, but then when you're trying to solve for b, to get b by itself, you'll add 880 to cancel the negative 880, and you will end up with b equal to 1,168. So Shamika's demand function is y equals negative 160 times x plus 1,168. She could then use this equation to give her some estimates. If she charged $6 per cupcake, she would probably sell about 208 per week. If she charged only $4, she would probably sell 528. She's selling a lot more, but making less per cupcake. In business, people use these kinds of equations to then figure out what they should price their product in order to reach a maximum revenue. The slope of our roof will be the rise over the run or the change in vertical over the change in horizontal. Notice it's 50 feet all the way across the roof. So when I'm actually calculating the slope, there's a rise of 8 feet for a run of 25 feet. So you want to use half of that total distance across the roof as your horizontal distance. So the slope will be 8 over 25. Suppose you have 3 tests in a class and you earned so far 84% and 90% on the first 2. Find what you need to score on the third test to have an A average for the test and then also to get a B. First, figuring out what you need to score to get an A, if we add 84 plus 90 plus whatever our third test is, that sum divided by 3 should equal 90 if we're striving to get an A average on the test. We're assuming that 90 is the bottom or the minimum for an A. 84 plus 90 subtracted from 270. Now where I got the 270 is I'm trying to solve for t, so I multiplied both sides of the equation by 3, and multiplying the left side by 3 canceled out the division, and 90 times 3 is 270. So subtract 90 and 84 from 270 and you get 96%. So you'll have to score a 96% to have an A average on your test. To get a B, however, we will assume that the minimum score is an 80. So to get a B average, we will need 84 plus 90 plus whatever we get on the third test, that's sum divided by 3 to equal 80. Multiplying both sides by 3, I will get 84 plus 90 plus t equals 240. So 3 times 80 is the 240. Then subtracting 240 minus the 90 minus the 84 leaves me with a 66% as what I need to get a B average on my test. Suppose your test average is 30% of your course grade, your quiz average 20%, your project's 25%, and the final exam is 25% of your course grade. Find what you need to score on the final exam to earn an A in the class, and then also what you need to score to earn a B in the class. So far, your test average is an 82%, your quiz average is 76%, and you've earned a 92% on your projects. Your test average was an 82, so taking 30% or 0.3 times 82 and adding it to 20% of your quiz average of 76, so 0.2 times 76, plus 0.25 times your project average, which was 92, that'll create a number, which is actually 62.8, to be added to 0.25 times your final exam score. If you're trying to get an A, you want that to equal a 90. We're assuming 90 is a minimum for an A. So 90 minus 62.8 should equal 0.25 times your final exam score. 27.2 is what you obtain when you take 90 minus 62.8. 27.2 divided by 0.25, though, gives you 108.8%, and that is too high to actually get an A. So you're not going to be able to get an A. Reworking the same calculation but setting it equal to 80 for the minimum for B, again the 30% of 82 added to the 20% of 76 added to the 25% of 92 is still 62.8. Your final exam is still worth 25% of your grade, but 80 minus 62.8 is equal to 17.2. So when you divide 17.2 by 0.25, this time you get 68.8. And that is actually doable. You could get a 68.8 and earn a B in the class. That sums up a little taste of applications of linear functions. We certainly could design infinitely many more possibilities, but this was just a taste. I'm sure Mr. Frank Lloyd Wright enjoyed some linear thinking as he sculpted his design, as this photograph from his Taliesin West home shows.